The force of attraction or repulsion between two point charges is given by Coulomb's inverse square law. Now here there are two charges, both are positive, kept at a distance of r. Since both of them are positive, there will be a repulsion. That repulsion is given by Coulomb's inverse square law. Force is directly proportional to the product of the charges and inversely proportional to the square of the distance between them. Newton's gravitational law, force is directly proportional to the product of the masses and inversely proportional to the square of the distance between the masses. The proportionality sign can be replaced by an equal sign after writing a constant k. The value of the k is 1 by 4 pi epsilon 0. Force is a vector quantity. To represent in the vector form, we will take this unit vector r12 cap. It is a unit vector from the first charge to the second charge. So in vector notation, the force between the charges can be written like this. Force is a vector quantity. So to represent the direction of the force, we can write r cap, where this is a unit vector from the first charge to the second charge. This epsilon 0 is the permittivity of free space. Value of epsilon 0 is 8.854 into 10 raised to minus 12. Its unit is coulomb square, Newton raised to minus 1, meter raised to minus 2. This can be obtained by rearranging this and getting expression for epsilon 0, where epsilon 0 can be written as 1 by 4 pi f q1 q2 by r square. Unit for charge coulomb, so it's square, by force unit is Newton, distance unit is meter. So we can get this unit from this expression. So k can be written as 1 by 4 pi epsilon 0. After substituting the value for epsilon 0 and pi and doing the calculation, you will get the value for k as 9 into 10 raised to 9. Suppose two charges each of 1 coulomb is kept at a distance of 1 meter. The force is given by this value, 9 into 10 raised to 9 Newton. If two charges each of 1 coulomb and kept at a distance of 1 meter will experience a force of 9 into 10 raised to 9. This is a huge amount. We will not come across such a huge value in our day-to-day life. So we will deal with the micro coulomb, nano coulomb, etc. Forces between two charges depends on the medium where it is kept. When these two charges are kept in air, this is the force, where epsilon 0 is the permittivity of free space. Free space means air or vacuum. Suppose the same charges are kept in some other medium. Instead of epsilon 0, we have to write epsilon. So this is the force between the two charges when they are kept in air or vacuum, where epsilon 0 is the permittivity of free space. Suppose the same charges are kept in some other medium. Instead of epsilon 0, we have to write epsilon. Epsilon is the permittivity of the medium. Different medium will have different permittivity. That means force experienced by charges will depend on the medium. This is one of the difference between gravitational force and electrostatic force. Gravitational force between two masses will not depend on the medium between the masses. But here the force will depend on the medium between the charges. Now, this is the force experienced by the charges when they are kept in the air or vacuum. This is the force between the charges when they are kept in a medium. If you divide this expression by this expression, we can compare. Here all the terms will get cancelled except this epsilon and epsilon 0. This expression is to be divided by this expression. So 4 pi and 4 pi will get cancelled. So this expression is to be divided by this. So 1 by epsilon into epsilon 0 by 1. So epsilon 0 divided by epsilon. If you take the reciprocal, F by Fm, F by Fm is equal to epsilon is called permittivity of the medium, epsilon 0 is permittivity of free space. This epsilon is always greater than epsilon 0. That means force between two charges is maximum when it is kept in air or vacuum. When it is kept in some other medium, force is going to be lesser. Epsilon by epsilon r is called the relative permittivity. Epsilon is called relative permittivity. So relative permittivity is always a number greater than 1. So F will be always greater than Fm. Force between two masses is given by Newton's universal law of gravitation. Force between two masses is directly proportional to the product of the masses and inversely proportional to the square of the distance between them. Force between two charges is given by Coulomb's inverse square law. Force is directly proportional to the product of the charges and inversely proportional to the square of the distance. So there is a similarity. But there are differences also. In the case of gravitational force, there will be only attraction. But in the case of electrostatic force, there are both attraction also, repulsion also. Then in the case of gravitational force, force will not depend on the medium between the masses. But in the case of charges, the force will depend on the medium as per this equation. If it is kept in air, epsilon 0. If it is kept in some other medium, epsilon. So the force will depend on the medium. Another difference is, in the case of masses, force will not depend on their motion. But in the case of charges, it will depend on the motion. So this expression is giving the force experienced by the second charge because of the first charge. So it is acting from the first charge to second charge. Positive, positive, there is a repulsion. The force is from the first charge to the second charge. So this is the force experienced by the second charge because of the first charge. Suppose you want the force experienced by first charge because of the second charge. It will be acting in the opposite direction, so we have to change the sign here. 1 by 4 pi epsilon 0 q1 q2 by r square. Instead of this, we have to, since it is in the opposite direction, so we have to change the sign. So it's a unit vector from first charge to second charge. Since it's a negative, you can change this. Instead of 1 2, you can write 2 1. So this is the force experienced by the second charge because of the first charge. This is the force experienced by first charge because of the second charge. So when it is here 2 1, here it is 1 2. Similarly here, this is the force experienced by the first charge because of the second charge, that is 1 by 4 pi epsilon 0 q1 q2 by r square. When it is this is the, you can write like this.